NASA's decision to select SpaceX's Starship for the Artemis moon landing marked a bold leap into a new era of space exploration, one defined by unprecedented ambition, radical reusability, and a scale never before attempted in lunar missions. This partnership between NASA and SpaceX signals a shift in how humanity approaches the moon, blending government vision with private innovation to push the boundaries of what's possible. Starship isn't just another lunar lander. It's a 50-meter-tall tower of stainless steel, promising to deliver more astronauts and cargo to the lunar surface than any vehicle in history. Its sheer size dwarfs anything that's come before, offering the potential for longer stays, more science, and even the first steps toward a permanent lunar presence. But with that scale comes a host of daunting challenges. Landing what is essentially a skyscraper on the moon's rugged, unpredictable surface is a monumental engineering feat, requiring new solutions for stability, precision, and safety. The rocket's towering height means astronauts will need a complex elevator system just to reach the ground, adding layers of risk and complexity to every mission. And Starship's massive fuel requirements demand a breakthrough in orbital refueling, something never before attempted at this scale or with this level of reliability. Each mission will require a fleet of tanker launches with flawless in-space fuel transfers that must work perfectly every time. The logistics are staggering, and the margin for error is razor-thin. No one has ever attempted such a complex ballet in orbit. As the deadline for Artemis 3 draws ever closer, the sheer difficulty of making Starship work on time has sparked urgent debate. Engineers and mission planners are asking a critical question. Is there a simpler, safer shortcut that could still achieve NASA's goals? Could we harness the groundbreaking technology of Starship, but trim the risk and complexity to make a moon landing more achievable in the near term? Enter a fascinating alternative, the so-called Stubby Starship. This innovative concept, now gaining traction among engineers and space enthusiasts alike, reimagines the lunar lander as a shorter, more practical version of Starship. One that could make the dream of returning to the moon both safer and more attainable. The full-sized Starship's biggest problem? It's not just about building the world's most powerful rocket. It's about making it work on the moon, a place with no atmosphere, unpredictable dust, and a surface that's anything but flat. Its height. At 50 meters, Starship is a true giant, top-heavy and imposing. Landing such a tall vehicle on the moon's rugged, uneven terrain isn't just tricky. It risks a catastrophic tip-over that could end a mission before it even begins. The crew cabin sits high above the lunar surface, so astronauts can't simply climb down a ladder like Apollo. Instead, they'll rely on a complex elevator system to reach the ground, a system that's never been tested in lunar gravity. If that lift fails, astronauts could be stranded inside, unable to step onto the moon at all. The stakes are enormous, and there's no backup plan for a stuck elevator. Then there's the fuel challenge. Over 1,000 tons must be loaded in orbit, demanding up to a dozen flawless tanker launches and transfers. Each tanker must rendezvous and dock with Starship, all while keeping the super-cold propellant stable. Every step, launch, rendezvous, docking, and cryogenic transfer, must work perfectly, every single time. There's no room for error, and no second chances in deep space. This chain of dependencies makes the mission fragile and slow. A single failure could delay the entire lunar landing for months, or even years. Meanwhile, Starship has yet to complete a fully successful orbital flight, or demonstrate in-space refueling. Two milestones that are absolutely critical for lunar missions. With the Artemis timeline under pressure and deadlines looming, doubts are growing. Can the full-size Starship really be ready in time to meet NASA's ambitious goals? The technical mountain SpaceX faces is immense, with every new test revealing fresh challenges to overcome. That's why some experts and engineers are searching for a more pragmatic solution, one that balances ambition with reliability and ensures astronauts can safely return to the moon. Enter the Stubby Starship, a bold new take on SpaceX's lunar ambitions. This is a shorter, lighter version of the original Starship, designed specifically to tackle the unique challenges of landing on the moon. Engineers and designers have reimagined the vehicle, focusing on efficiency, safety, and practicality for lunar missions. By trimming the propellant tanks and reducing the overall height, the vehicle now stands at about 35 meters tall. This significant change instantly lowers its center of gravity, making it much less likely to tip over on the uneven lunar surface. The result? A more stable, less top-heavy lander that's still far larger than Apollo's legendary lunar module, but now much easier to handle and operate. This new design could make lunar landings safer and more reliable for astronauts. The Stubby Starship keeps the same powerful Raptor engines and advanced onboard systems as its bigger sibling, but it trades some raw cargo capacity for a dramatic reduction in risk and complexity. With less mass to move, it needs far less fuel to reach the moon and return. This means fewer tanker launches are required for each mission, which simplifies planning and reduces the chances of something going wrong in orbit. The crew cabin now sits much closer to the lunar surface, making it easier and safer for astronauts to exit and enter the lander. This could even eliminate the need for a risky elevator system, allowing for quicker and more direct access to the moon's surface. Instead of a marathon of tanker launches, a Stubby Starship mission could require just 2 or 3 refueling flights in Earth orbit. This streamlines the entire process, making lunar missions more efficient and less expensive. In the end, the Stubby Starship offers a streamlined shortcut to the moon, making lunar landings not just more achievable but potentially a reality much sooner than anyone expected. The Stubby Starship's biggest win? Stability. A lower center of gravity means safer landings on the moon's unpredictable surface. For astronauts, that's peace of mind, and a better chance to explore. Building a smaller vehicle is also faster. Fewer parts, quicker testing, and a shorter development timeline. That could keep Artemis on track for a lunar return this decade. With the crew cabin closer to the ground, astronauts could use a simple ramp or stairs. No complex lift required. Moving equipment and samples becomes easier and safer. Fewer tanker flights mean less risk, lower cost, and a more manageable mission. The Stubby transforms orbital refueling from a monumental barrier into a practical hurdle. It's a pragmatic path to the moon. But the Stubby comes with trade-offs. Its smaller tanks mean less payload. No 100-ton deliveries, just the essentials for early missions. Building a lunar base would take more flights, shifting complexity from each mission to the overall program. More frequent launches could require new space infrastructure sooner than planned. Critics argue the Stubby distracts from SpaceX's Mars ambitions, diverting resources from the full-size Starship. The original design's huge margins offer safety and redundancy. The Stubby is more optimized, but less forgiving. By simplifying for the moon, we might lose the robustness needed for deep space. The shortcut could come at the cost of future capability. It's a calculated risk. The space community is split. Stubby supporters are pragmatists, focused on landing safely and soon, even if it means less cargo. They see it as a smart, risk-reducing step, and a valuable learning experience for future missions. Purists argue that any detour delays solving the real challenges, like large-scale refueling, needed for Mars. They believe SpaceX should tackle the hardest problems now, not sidestep them. For them, the full-size Starship is the only way to unlock a true interplanetary future. The debate is about more than hardware. It's about vision, priorities, and the path to the stars. Both sides want the moon, but disagree on how to get there. Whichever Starship lands, the road to the moon is steep. SpaceX must first prove Starship can reliably reach orbit and return, a milestone still ahead. Orbital refueling is the linchpin. No one's done it at this scale, and it must become routine. Without it, lunar landings remain a dream. Beyond the rocket, a vast support network, launch towers, production lines, mission control, must be built. Artemis isn't just a lander, it's a transportation ecosystem. The journey will test human ingenuity and perseverance, one problem at a time. The Stubby offers a pragmatic shortcut, the full-sized Starship, a bolder leap. The moon awaits, patient as ever. The choice we make will shape the future of space exploration.